All right, yesterday we talked about how to find the lengths of two chords. Part times part equals part times part. Well, let's give a little love to, what do we call these two up here? Secants, and also what's AB in the second diagram? Tangents. All right, well, how do we find the lengths of them? All right, because that is a whole new theorem. And actually, I don't like the word theorem here. I actually like the word, it's a saying to remember. If you ever want to find the lengths of tangents and secants, here is the same to remember. Right? Whoa, relax. Okay, try that again. Whole times external. And when you hear the word external, first word that comes to mind? Outside, yeah. So we're going to be talking about the piece outside the circle. Whole times external equals whole times external. That's what I'm going to have you remember when we're talking about lengths, tangents, and secants. And don't move on at all down below. Look at my first diagram on the top left. You guys said I had two secants, right? Name a whole one, please. Name a whole secant in that diagram, and I'll show you how this works. Two, name a whole secant. EA. So everybody ready? EA whole times the external part of EA. Name that part. External part of EA. 16. DA equals, now I go to the other secant and I do whole times external again. Give me the whole secant in the other one. 16 again. CA times its external part. It's 9. BA. There you go. So that's how it works. I do want to go to the second diagram because I want you to notice something when you deal with a tangent. It's a little unique for whole times external. Maybe you guys can already see it. But first, give me the whole secant up here. Give me the name of the whole secant. 4, whole secant. DB. Times, how about its external part? 9. CB. Now go to the tangent. Whole and external of the tangent. 20, what's the whole tangent?
AB.
And its external part?
AB.
Same thing, right? Everyone agree? Whole and external, the whole tangent's on the outside already. So they're both the same. All right, so anytime dealing with the tangent, those values should both be the same. Got calcs ready to roll? Let's go to this. All right, let's put some numbers to this. All right, diagram 1, everyone see 2 secants, right? 2 secants. Hey, your brain's not going to like this, though, because your brain is still in yesterday mode, and it's going to say 5 times 10 equals 4 times x. Are these chords? Then I can't use it. All right, I know that's the way you want to transition, but we got to fight that urge and go, oh, these are 2 secants, so give me the length of one of them. 12, length of one of the secants. 15 times, now give me its external part. 5. And then how about, ooh, be careful here, watch your mouth. The other whole secant length. Watch your mouth. 27. 10.
4 plus x.
4 plus, not 4x. I add the parts together to get the whole length. 4 plus x times its external part. 2.
4.
4. There we go. Little whole times external. Make sure you distribute the 4, please. And there are rounding directions up above. Round to the nearest 10th when you get there. 10th. When you get it, nearest 10th, let me know. 9 when you're ready.
I got 26.
You did. Is that the new math I don't know about?
I don't know.
75.
Oh, yeah.
All right, regroup. Let's go. Regroup. Bad class when Pedro's correcting you. Right?
Well, 14.75.
Okay, 14.8. We got it. I hate to break this news to you guys back there, but we're going to go up in difficulty here. Each one here a little bit. All right, we got it. All right, we got the jitters out, I guess. All right, next one. Secant and a tangent. Give me the whole secant length. Whole secant length. Oh, 6. 11. And how about its external part? 25. 2. And let's go to that tangent. What do you know about the whole and external part of that tangent? 12.
It's the
Same.
same.
Y times y. Y squared equals 22. I don't need to factor, right? I don't need to factor unless it's y squared with a y. And here, I can just take the square root, round to the nearest tenth when I'm ready. Let me know when you're ready. 8. Okay. How about 24? All right. 2 for 2 right now. 4? 4.7. Any issues? Okay, next one. 2 secants. Just watch yourself when you combine when I say the whole. Name one whole secant length. One whole secant length. 2.
Not entirely sure.
One whole secant. So let's start with the one that says 8 and y. How do you represent? No.
8 plus y.
We don't multiply when we add the parts. 8 plus y. As you can see, that drives me nuts a little bit, right? When you combine the parts, you got to add them together. Everybody good? Now everyone's nervous to answer. What's the external part? 16? 8? The next whole secant. If anybody says 7y plus 21, immediately leave. Okay? 17.
10 plus y.
There you go. I'll write y plus 10. And then its external part, 7. There you go. Go to town. Should not need any rounding here, right? Any rounding. We'll keep that part in the video too. Mr. Cardinal transforms into the whole. No rounding needed. 19. Yep. All right, next up. We got a problem in the next one. Now look, now I added chords into the diagram. Just not tangents and secants. Let me do the incorrect work right now. And you guys tell me why you don't like what I'm going to write up here. I'm going to try to do whole times external. All right, with the tangent and the secant that's in the diagram. So I'm going to go y times y. We're all good there? That's the tangent, whole times external. Now look at the secant. N, Q, M all the way to the outside. I got a 4, I got an X, and I got a 6. Combine them, I got X plus 10. Everyone agree? And I'm going to stop right there. You got a problem with that? Because I certainly do. We don't like to solve an equation with both X and Y in there. So are we okay on why whole times external won't work? Isn't there something else other than secants and tangents in there? What other type of segment do you see in there that maybe I could use? 25, I see tangent, secants, and chords. And 2 chords that intersect. What did we say yesterday? If 2 chords intersect, their parts are equal to each other. So everyone look at one chord right now and tell me the two parts of one of them. Two parts of one of the chords. 21, what do you got for me?
10 and 3.2.
Yeah, Dan, there you go. 10 and 3.2. Now look at the other chord. Give me its two parts. 15?
4 next.
There you go. I can solve this. Definitely. I want you and your group to solve X and then go back and do whole times external now to find Y. All right, go ahead. I'll give you a few minutes. And now use your value of X to go back and find Y.
Okay, 4.9.
I'm not sure.
Oh, wait, yeah. Being 10.4.
What did I do?
No, we should be there.
Wait, what?
Okay, listen.
18 times.
What's your BPM right now?
18 times 6.
No, no, I told 8.
It's all of it, and then the outside.
No, I feel right.
If you did 12, you're wrong.
Oh,
It's a
All right, so you got 8 for X, right? You plug 8 back in, that makes that whole secant 18 units. Times its external part 6, you get 108, take the square root, and we get 10.4. All right, so yeah, you might see a diagram that's got just more than secants and tangents, but you can handle it now. All right, this doesn't look too bad, huh? Just what? Got a secant and a tangent. Write your whole times external equation. Go ahead. I'm going to help you solve it, but I want you guys to produce the equation first. So go ahead, write your whole times external. All right, what do you got for me? What's your whole times external equation I can use? 25.
2x squared plus.
No. Don't get ahead of me, Jay. I just want the basic whole times external equals whole times external.
Oh, okay. So
2x
plus 4
times.
X.
Yep. There's secant. There's the secant. And what about the tangent?
10 times 10.
There you go. All right, so we're all good on the whole times external because we got to have that. All right, go ahead. You can distribute the X. Go ahead. Distribute the X and we'll talk. So I get 2x squared plus 4x equals the 100. All right, I'm trying to drill this more and more into you, especially when you go to Algebra 2 next year, if you make it. X squared and the X. If you have both in the same equation, it's going to be factor time. All right, hey, if I just had 2x squared, I could get rid of the 2 and square root, but I can't here because the X is attached. We're not factoring unless the what? Equals 0. You guys know, yeah. Pretty dominant fact this year. So move the 100 over. 2x squared plus 4x minus 100 equals 0. And then from here, I'd be like, all right, go play in your calculator. Think about it in your head. 2 numbers that multiply to 100 but add to 4. Not here, though. That method only works when the number out in front, your A value is 1. It's not. It's not. So I can't use that method right now. I need some help. Can't use that method. 2 numbers that multiply by 100 and add to 4. We have 2 options right now. Could I make that A value 1? What could I do to each of the terms? Divide by 2. Everyone, right? Divide by 2. Everyone agrees? All right, let's try it. Divide by 2. Get rid of the 2. You're basically taking out a 2. Divide by 2. I get x squared plus 2x minus 50 equals 0. All right, now I can play around in my head in my calculator. Two numbers that multiply to negative 50 but add to 2. You can keep playing around for a minute, an hour, days, forever. You're not going to find those two numbers. They don't exist. So last ditch resort, if you're not good at factoring, you just don't even want to try it, or you notice that there are not two numbers. That's why everyone's got a formula sheet, because we are about to use off this formula sheet quadratic formula. Yes, whether you like factoring or not, you can always rely on quadratic formula. Whoa. I see an A, a B, and a C in the quadratic formula. I'm going to need your help finding out what those values are before I substitute them in. A, B, and C. Who's going to rifle them off here for me? 14, A value. Not here. Thanks. Appreciate it. I figured with all the silence. Thanks for letting me know. 2. Usually you guys just jump right down my throat when a number comes up. Not here! I'm like, all right, relax. I get it. Relax. Not that time, though. What number are we at? Oh, 2. By the way, I apologize for how I reacted last time. My bad. Get out of here! You did it again! Got him! That's twice!
A value is
Wait till number 3 comes later in the year. Get out of here. What do we got? A value. 1. B value. 2. C. -50. All right, you got that. Good. All right, now look at quadratic formula. X equals, I believe it says negative B, right? Well, my B value was 2, negative B, negative 2, plus or minus. When you plug inside the parentheses, put them in parentheses. When you plug it in, inside the radical, put your numbers in parentheses, because that's what I want you to do when you use your calculator. Use parentheses. You can't go wrong. So what's underneath the radical? B squared, right? So watch. 2 squared in parentheses. Minus, the 4 doesn't need it because I'm not substituting in. A, 1. C, negative 50. All over 2 times, what's my A, 1? So everyone's going to get a fraction template out. Negative 2 plus all of it. But then you're not done. You should have a second answer by doing negative 2 minus all of it. So go right ahead, type away. You should have 2 answers, the negative 2 plus version and the negative 2 minus version.
Wait, you don't add the whole again.
and then the bottom.
Yes, you should get a negative answer and a positive answer. Hopefully you're putting everything in the parentheses that needs to be. I'll let you guys go, and then the directions do say round to the nearest tenth, so.
Because you pause, just go positive and are you putting the 1 in there? The 1 is there. Yeah, same. Negative 8. Wait, you did it right. What did you do?
Also, I've been noticing today, make sure you don't mix up when it's a negative versus the subtraction sign on your calculator. All right, the 2 should get a negative, but in here you should use your subtraction button. All right, make sure you don't mix those up because your calculator is going to respond a lot differently.
Use the negative sign.
All right, here's what I have here so we can move on. I got 6.1 for the positive version and negative 8.1 for the negative answer. We're good there? We got an it. No, I'm not good. Come on, we've been in this class a while here, months. One of those doesn't make any sense. Let me know which one and why. 17, which one doesn't make sense?
The negative one.
Why?
When you add them up, they won't equal.
Go ahead, plug that in for AC. Good luck. You're going to have a negative sideline. You're going to have, it's not a side, but a negative segment. No go. You and your group, you got the last one. All by yourself.
You guys get.
Oh my god.
I think me and Bruce must have mixed each other.
What is it? I know.
Yeah, but it was just like once in quarter one.
Whole times external. Whole times external, not internal.
What am I even doing?
Oh, there's 12.5, yeah.
8, okay. 2.5 times.
Yo, yeah.
Hopefully you found the external part to be 8. 12.5 minus 4.5. X squared is going to equal 100. So dA will be 10. Grab yourself some textbooks and let's make use of this 13 minutes we have. You could realistically walk away with nothing this weekend.